In this video, we'll be going over problem 7 in the January 2020 CXC Math exam. In this problem, we are given a sequence of star figures made up of sticks and dots. In part A, we're asked to look at the patterns in these figures and fill out a table. In part 1, we're asked to figure out the number of sticks that are in figure 5 and the number of dots that are in figure 5. So let's start by looking at the number of sticks. If I look at figure 1, I see that we have 12 sticks. In figure 2, we have 24 sticks. Figure 3, we have 36 sticks. A pattern that you might observe is that each time the number of sticks goes up by 12. Right? To get from 12 to 24, we add 12. To get from 24 to 36, we add 12. And to get from 36 to 48, we add 12. And this should make sense to us because going from one figure to the next, all we're doing is adding in a larger star. So going from figure 1 to figure 2, I add a larger star, so that's 1 stick here, 2 stick here, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 more sticks. So to figure out the number of sticks in figure 5, we'll take the number of sticks in figure 4, which is 48, and add 12 to this. So 48 plus 12 gives me 60. Another pattern that you might observe here is that the number of sticks is just 12 times the figure number. For example, in figure 1, we have 12 sticks. In figure 2, we have 24 sticks, which is 2 times 12. In figure 3, we have 36 sticks, which is 3 times 12. And in figure 4, we have 48 sticks, which is 4 times 12. So for figure 5, we can also compute this by doing 5 times 12, which again gives me 60. Now let's look at the number of dots. In figure 1, we have 13 dots. In figure 2, we have 25 dots. In figure 3, we have 37 dots. Again, notice that each time we're adding 12 more dots. Right? 13 plus 12 gives me 25. 25 plus 12 gives me 37. 37 plus 12 gives me 49. And this should make sense in terms of our picture as well. If I go back to figure 1 and I want to try to get figure 2, I would add in 1 dot here, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And this pattern keeps on going because each time we're adding in the same star that's only a little bit larger. So to get the number of dots in my fifth figure, I can take 49 and add 12. This gives me 61. Another pattern that you might observe here is that the number of dots is always 1 more than the number of sticks. This extra dot that we have is the center dot that's in each of our figures. So now let's go to part 2 of this problem. At some point in our table, we know that the number of sticks is 156, and we're asked to figure out what figure number this is and the number of dots that we'll have. The number of dots is easy to figure out because, again, it's always 1 more than the number of sticks. So if I have 156 sticks, I know that I'll have 157 dots. To determine the figure number based off of the number of sticks, we want to remember the pattern that the number of sticks is equal to the figure number times 12. Right? Again, this is what we observed earlier. For example, in the first figure, we have 12 sticks. In the second figure, we have 24 sticks, which is 2 times 12. In the third figure, we have 36 sticks, which is 3 times 12. So if I take my equation here and divide by 12 on both sides, I get that my figure number is equal to number of sticks divided by 12. So in my table, the figure number for 156 sticks would be 156 divided by 12, which gives us 13. So that's the figure number. Lastly, in part 3, we are looking at figure n, and we want to determine the number of sticks and the number of dots. Now n is any arbitrary natural number, so here the number of sticks, remember, is always 12 times the figure number. So what I would write in this entry would be 12 times n. And the number of dots, remember dots is always one more than the number of sticks, so I would write in here 12n plus 1. So that's how we fill out the table in part A of this problem. In part B of this problem, we want to find the sum of the number of dots in two consecutive figures. In the first part, we want to find the total number of dots in figure 7 and figure 8. Now, what we'll be using here is something from part A. In part A, we determined that for figure n, the number of dots is 12n plus 1. So the number of dots in figure 7 would be 12 times 7 plus 1. The number of dots in figure 8 would be 12 times 8 plus 1. And what we're asked to do is to add these number of dots together to find the total number of dots in these two figures. So calculating the number of dots in figure 7, we have 85 dots in figure 7, and then in figure 8, 12 times 8 plus 1 would be 97. Adding 85 and 97 together, we get 182. So that's the total number of dots in figures 7 and 8. For part 2 of this problem, we want to find the total number of dots in figure n and in figure n plus 1. Our approach here is very similar. In figure n, I'll have 12n plus 1 dots, and in figure n plus 1, we'll still use the formula, but instead of plugging in n, we'll plug in n plus 1. So I'm doing 12 times n plus 1 and then plus 1. And then we'll add these two things together to find the total number of dots in those two figures. Let's simplify this expression a little bit. We have 12n plus 1 plus, if I distribute the 12 into n plus 1, I have 12n plus 12, and then I still have that plus 1 in the end. When I combine the like terms, I get 24n plus 14. So that's the total number of dots in figure n and figure n plus 1.